Good afternoon and good morning to those of you out west. Welcome to today's webinar from Metal Architecture Magazine and AEP Span. My name is Stacy Ranella. I'm the editor-in-chief for Metal Architecture, and I'll be moderating today's presentation. Just to cover a few housekeeping items before we get started, it may take up to 5 business days if you are requiring a certificate, so keep an eye out on your inbox and don't forget to check your spam or junk folder. If you have any questions during today's webinar, please enter them using the Q&A section, which you can find at the bottom of your Zoom window. We will address as many questions as possible during and at the end of the presentation. Zoom does have a raise hand function, but since we'll be keeping everyone's mics muted, only use the Q&A instead. If you're experiencing any technical difficulties during the webinar, you can enter a message in the chat, which you'll find right next to the Q&A, and we'll do our best to help. Today's webinar is being recorded and will be available on Metal Architecture's website by this time next week. Now I'd like to introduce our speaker, Jeff Medeiros. Jeff is the architectural representative for AEP Span and is a licensed contractor who has been supporting architects in California for more than 20 years. Jeff can spec write, assist in detailed drawing, and aid in product selection or any aspect of the design build process from initial design to complete bid-ready documents. He's fluent in building code, bid laws, and contract code. He provides architects with a full range of services from conception through bid. He holds various degrees, including Law and Society from UC Santa Barbara, Japanese from Waseda University in Tokyo, and he attended McGeorge School of Law in Sacramento. He's fluent in all types of roofing systems, built up and torch applied, hot and cold process, and restoration coatings such as silicone urethanes and acrylics single ply roofing. He is also fluent in all forms of metal applications, including roof wall coping and soffit, as well as flashing trim. Jeff made the move to AEP Span over 7 years ago after spending years with a competitor and plans to stay on through retirement. In this webinar, Jeff will discuss metal roof systems, design, and installation considerations. Jeff, we appreciate you joining us today. Please take it away.
Good morning, everyone. Hope everyone's doing well. Thank you for jumping on. So let's kick this off. Metal roofing design and installation considerations. The only slide I think I have to show is this one for your credit, your Learning Units 1.0, and the course numbers listed in the upper right. So let's jump in. The first thing that I want to talk about is architectural roofing versus industrial roofing, okay? Architectural roofing, I want you to think of as the pretty stuff, all the stuff that has the colors and pops and the designs that you want to make your building pop. Industrial roofing, I want you to think more metal building, okay? While industrial roofing has a great application, it can also be used on our architectural type designs and structures, but it does have that industrial look, okay? Industrial roofing is always through fastened. Okay, so architectural again is going to be that pretty stuff. It's going to be your concealed fastener panels. If there's one thing I want you to take away is I want you to take away architectural roofing, concealed fastener, industrial is exposed fastener, okay? So architectural roofing is, again, that pretty stuff, right? It's specified for life cycle costs and aesthetic reasons. These are the ones that you can come through and you can put different profiles that interlink on walls or standing seam on roofs with concealed fasteners. I'm going to talk about roof and walls. I know this is roofing, but walls play in as well. So industrial type roofing is your through fastened panels. So again, your pre-engineered metal buildings that you're going to run fasteners through and be done with. On the walls, it's the like the vineyards or metal buildings where you run through fasteners through and you want that more industrial look, okay? I'm going to skip past that one. So exposed fastener panels, by definition, they're through fastened, right? Exposed fasteners. They're nestable. What I mean by nestable is they alternate back and forth, right? Because they're all corrugated, and I don't care what corrugation you want to pick. You can pick your, 1800s old-timey gold panning sine wave, or you can pick a box rib or a trapezoid or a diamond, whatever you want. They alternate and they're all slanted so you can nest them. And because you can nest them, you can ship them easier. They ship on pallets, right? As compared to like a standing seam system where if it's 12 inches wide, you can't fit another panel within that same 12 inches. It's the same size, right? You can't nest them. So it's nestable. And because they're nestable, they rely, number 3, on laps and sealant for waterproofing. Again, I don't care what profile it is. You can pick sine wave, box rib, diamond. They're all corrugated. They're all through fastened. They're all nestable, and they all rely on laps and sealant. You can put them on roof. You can put them on walls. Here's a photo of it on the walls. Typically speaking, industrial roofing is going to be your lighter gauges, especially for the pre-engineered metal buildings. You're going to have your 26, 27, 29 gauge, although they do come in your architectural gauges of the 24, 22, and 20. Okay. So as you can see right there where I'm circling with my mouse, they're nestable and they rely on laps and sealant for waterproofing, right? Okay. So because they are through fastened, they are pinned at every attachment point, and they don't really allow for thermal cycling, right? That's the panel heating up and cooling, heating up and cooling. I go off track on these slides a lot, so here's another tidbit for you. Steel typically moves 1/8 of an inch over a 10-foot stick, 1/8 of an inch. Aluminum, if you think back to your materials classes, first year, right? That moves in sheet form about 1/4 of an inch per 10-foot stick. So if you have a long panel run and you have through fasteners going through this thing, and it's on the roof, and it heats up, it wants to move, but it can't because they're thermally pinned, right? So to a certain extent, each corrugation acts as a spring to absorb some of that movement, but it's not going to absorb everything. So over time, what'll happen is those panels will move and the fastener's there and it makes a hole and it starts to elongate. That's why you see backed out fasteners on the roof or large openings. An example of this is a nail in your fence. You've walked by taking your trash out and you go, oh my gosh, there's nails popping out of my fence. Yeah, the nail's heating up and cooling off. The wood is expanding and contracting. Same thing happens with these exposed fasteners, okay? So it can be a maintenance issue. As they age, you're going to want to check them every year at least, right? But that's what happens to those panels because they are pinned thermally. Typically speaking, you shouldn't use them over a conditioned space on slopes less than 1 in 12, if at all, over a conditioned space. Code limits through fastened panels to 112 with laps or soldering, laps and sealant or soldering, and they're limited to 312 if you don't have that. Okay, so in certain cases, like when you have a conditioned space, for example, a standing seam metal roof is going to be your choice. Okay. Everything these architectural panels have, also known as concealed fastener, is the opposite of the exposed fastener. Okay, they don't have exposed fasteners. They're concealed. If you look here, there's a clip with fasteners going through and the panel goes over it, right? Concealed. Concealed fastener. Number 2, they are not nestable. You can't ship a 12-inch or a 16-inch wide panel inside of that because the standing seam legs are the same distance across, right? You have to flip them and alternate and stack them. Okay, so shipping tends to increase. Oh, that's my dog. Shipping tends to increase. Okay, the third issue with them is they do not rely on laps and sealant. They rely on the standing seam leg to encapsulate. This talks about a bearing plate with rigid insulation. I think I've got a photo of that somewhere. Maybe not. Okay, so let me talk through this. A bearing plate is a snowshoe, okay, for the clip. So if you're going to install these panels over polyiso, for example, your deck, metal deck, insulation, and then you don't have a Dens deck, for example, you want to install them right over the polyiso. Well, polyiso has a compressive strength of about 25 psi. I can't walk on that roof. I'll leave a footprint. You can't walk on that roof either, right? So if you put a clip that has that footprint and you tighten the fasteners, under tension, it's going to sink into the ISO. So what happens is you want a bearing plate. A bearing plate is about 4 inches by 6 inches. It's pre-punched. The clip slides into it, and it distributes the weight of that clip footprint under the fastener tension, and you don't sink into the ISO. So in lieu of a bearing plate, you use a Dens deck or exterior jip, which has a compressive strength of 900 PSI, right? Clip won't sink in. Also, that exterior jip allows you to hit your Class A fire rating in the majority of cases. So bearing plate over rigid, so it won't sink under the fastener tension and compromise your roof, or exterior jib. Moving on. There's a couple different types of standing seam concealed fastener. The one in the upper left, snap style. That is a male leg with a female leg that encapsulates the male leg with a beaded sealant, and you push and click, and that's why it's a snap lock, and it runs the length of the panel. Easy. There's mechanically seamed. One leg fits inside the other, then a mechanical seamer runs down the entire length of the panel. These are good down to a 1/4-12 slope. That's the lowest slope allowed under code without moving to coal tar pitch, but we don't like coal tar pitch. I don't like getting cancer either. So 1/4-12 is the lowest slope allowed. This can hit that. The 180 is the exact same type as this, but it's hemmed an additional time. Hemmed once, hemmed twice. So when you're in plan view, do you want it larger or smaller? Okay, then there's batten seams. The batten covers the adjacent panel, right? So these panels come in and they turn up, and the clips have tabs that fold over. The batten goes over the top. Because these don't have an interlocking panel leg like the above panels, the snap locks or the mechanically seamed panels that all encapsulate each other, right? These just come up and go together, then a batten goes over the top. These are limited to a certain slope, 312. Maybe you can get away with 2.5 and 12, and it's because the batten just covers the top. There's no additional protection from the other panel leg, right? Okay. I went to the next screen, but it didn't move. Here we go. All right. Again, no clips visible, and thermal movement can be unlimited or it can be contained, but I'll talk about that in a sec. One-piece clips. One-piece clips allow the panel to slide over the top, okay? That is unlimited thermal movement. Awesome. Two-piece clips. Two-piece clips are limited in movement. Two-piece clips have a tab, and the clip moves. They are mechanically seamed into the panels. Right? Great wind uplift, 1/4-12 slope, great waterproofing, awesome. But they're limited by the movement within the clip. If you have a plus or minus of 1 inch, for example, and granted, there are some mechanically seamed panels that have unlimited thermal movement, which are the bulb seam or T-seams. Those tend to be drastically more expensive. And you can achieve the same thing with this. I'll show you down the road. But these are limited to plus or minus about 1 inch of movement. Now, if you think back to what I said earlier, or to your materials class, your first year of school, steel again moves 1/8 of an inch, aluminum sheet, this is sheet form, moves 1/4. If you have an 80-foot long panel in steel, that's as much as that clip can accommodate. I'll talk about how to run longer panels in a little bit. But there's the thermal cycling is very important to take into consideration. Also, I'm going to go off track again real quick. Steel in rolled form and sheet form does have better wind uplift characteristics than aluminum. Sometimes you need double the clips to hit the same uplift. So oftentimes aluminum is difficult in high wind areas, snow loads, FM type projects. Also, steel has a memory while aluminum doesn't. And what I mean by that is think back to your grandfather's truck, right? You're going to wherever, shopping to a hardware store, and the shopping cart hits the door. And he goes, we'll take it home, pop off the door panel, and hammer it out, right? Fixed. Do that with a modern car? I don't think so. With fiberglass and aluminum, yeah, right? Aluminum doesn't have a memory. If a ball hits it, if you use it on a wall, and on the impact zone, as I call it, where people like to interact with it, and someone leans up against the panel and has a cigarette or takes a phone call, or a kid kicks it when they break up with their girlfriend or something, it won't pop back out. Steel can. So some things to take into consideration there. There's my bearing plate. Talked about it earlier, right? About 4" by 6" pre-punch. The clip slides in, distributes the weight. Distributes the footprint of the clip under tension with the fasteners. Again, choice 1 over insulation is bearing plate, so it doesn't sink. Choice 2, in lieu of this, is going to be your exterior jip, and that jip also gives you a fire rating in almost every instance over a combustible deck. Okay, continuous standing seam panels can be used. I'm going to go off track again here. You have a client that's doing what's a big roof? A gymnasium, right? They're doing a gym over a basketball court or something, and it's a shed roof, and they have 100-foot long panels. Okay, we can roll form on site. A lot of people can. There's quite a few on-site mobile roll formers out there. Here's the thing. You have a 100-foot long panel. You have to get the roll former to the site. You have to hire an operator for the roll former in the field. If it's a prevailing wage job, that operator is now part of the construction project, and they're operating at prevailing wage costs, not inside the manufacturing facility. You have to have a 100-foot run-out length for the panel as it comes out the roll former, okay, on site. Now, you have to have one person per 10-foot length of that panel to move it under OSHA, right? Okay, so there's 11 people to move a 100-foot long panel. At a prevailing wage job, that's at metal workers' wages. You just added a lot of money to move that panel. Now you have to be able to stack it on site. Okay, how do we get it onto the roof so it doesn't bend and twist? Good question. You have to hire a crane operator and get a crane on site. But you can't pick it at either end because it'll bow in the middle. It's 100 feet. So how do you support the panel? You rent a spreader bar. A spreader bar goes from 2 pick points to 2 4 pick points to 2 4 6 8 pick points, or as many as you need. It lifts the panel up. Your crane operators oftentimes make about as much as surgeons. Let that sink in for your construction cost. In addition to that, you need site control. You need a flag person. And if you're over a city center, you're going to need to block off access to streets. Okay. In addition to that, you must have perfect weather conditions. Because if you're going to lift a 100-foot long panel up and a gust of wind catches that panel, okay, it's going to spin the panel. That is not good. You're at a 100-foot long panel, not a short one. So there are costs associated with running long panels. We can do it. Continuous seam, we can do it. Or you can lap them. Either way. Did I paint that picture? They're prone to installation damages and a lot of additional challenges. So there you go. Okay, if continuous panels are required, make sure you have a UL certified roll former. A lot of these roll formers aren't UL certified. You have guys in Alaska that can only roof or do wall panels within a certain window, and they have their roll formers that they bought second and third hand from companies, okay? Make sure they're UL certified so all the testing follows that panel and you can get through your state architecture, your DSA or whatever other institution you have to get through. They must be quality, must be UL certified, and all the testing must follow the panel. Okay, real quick, substrates. You can install roofing over in a substrate that is not true, but it will follow it. Here's picture proof, okay? Make sure your substrates are solid, or you have a strong enough gauge to be able to go over that substrate. You can also install over open purlin. You will see a dip, but it will follow the substrate if it's not true. Okay, underlayment. Underlayment should be high temperature, self-adhering, which is peel and stick, right? Non-sanded, because if the metal is laying on the underlayment and it expands and contracts, you don't want that to sand the back of the panel. A lot of bituminous rolled goods are sanded so they don't stick together during shipment. You don't want that, okay? You want it self-healing, so when screws or nails go through it, sucks around it and it's waterproofed. Okay. Next slide is one of my favorite photos. So Jeff, why do I need high temperature metal underlayment? Why can't I use 30-pound felt? I've always used 30-pound felt. Oh wait, it's one more down. Ready? Here we go. Because 30-pound felt will re-emulsify under hot temperatures. This is in Redding, California, where it hits 120 degrees. And I think today it's 110 or 115 in Redding. Okay. Can you imagine if you built a brand new building and you use 30-pound felt that re-emulsified under hot temperatures and ran down the outside of the building instead of on to the built-up area like this did, use temperature-rated underlayments. There's proof. Okay. The one thing, I went back one slide. The one thing I do want to talk about real quick is if you do have areas that have different conditions that require a different underlayment, such as ice, refrigeration structures, pools, and so on, this may not be the best thing to use. We can talk about that later, but it's this in 90% of the cases is solid, okay? Also, this is considered dried in. So once this is applied, if a rainstorm hits, if you're in Seattle or Portland, right, where you can only roof 2 days out of the week because it's raining the arrest, this is considered dried in. Okay. Exposed fastener roofs, like I said earlier, come in lighter gauges, 26, 28, 29-ish. That's pre-engineered metal buildings, your gazebos and stuff like that. Exposed fasteners can come thicker. You can use them on carports and so on, but generally speaking, for pre-engineered metal buildings, they're lighter. And then standing seam is always going to be 22, 24, 20, okay? We can do it in different metals, like I said earlier, aluminum and steel, right? Okay, here's our first break. Do we have questions so far? I saw a couple come through.
Thanks, Jeff. We do have some questions. First question, is there a significant difference between sloped and vertical installation?
So in terms of how you handle the panels, yes. In terms of waterproofing, no. Okay. So if you go more, like, low slope is difficult to me. As soon as you start going up slope, great. You can go vertical. There's your wall. So for example, those batten panels you can only use on 3 and 12. You can use them vertically all day. And standing seam on the walls is gorgeous. It's absolutely gorgeous. And it's easy to do because you treat the top of the wall as the ridge and you pin it and let it float down the wall. It expands and contracts down the wall. Going low slope is where your concerns are. And low slope undercoat is considered anything under 2 and 12. So there are limitations going down, not going up.
Okay, next question. Is it possible to unseam damaged standing seam panels in the middle of the field for repair?
That's the one that I saw come through. That is a fantastic question. Whoever asked that, give yourself a gold star today, okay, from me. If they're directional panels where you have a male leg and a female leg that entraps it, you need to pull off every panel to the female side to reach that panel, okay? Because you can't unseam them in the middle, okay? That's a directional panel. If you do not have a directional panel where they come together and they turn up with a batten, you can pop the batten seam and replace one panel. So my answer is it depends on if the panel's directional, i.e. male-female leg, whether it's snap lock or mechanically seamed, or if it's a batten where they come together and go up and then a batten cap goes over the top. And again, batten panels are also snap lock or mechanically seamed. So directional versus not directional panel is your answer. And that's a great question.
Okay, we've got another good question here. I've heard it's better and possible to fasten an exposed fastener roof panel through the high point of the corrugation to minimize leaking potential. What is your take on this?
That is, man, we got some gold stars today, huh? Good job. Give yourself another gold star. We have 2 so far. Yes, that is how you want to fasten panels, generally speaking, is through the high point. There are going to be some instances where you have to fasten through the low point. You hit that on the nose. The corrugation, whatever it is, let's take a sine wave, for example. It's going to hit the top and go off. So no water is going to travel down that flute. Whereas in the low point of that, I forget the crest and the trough. Think back to math, right? The low point of that panel is where all the water runs. So if you have a fastener in the low point, you are more susceptible to having a leak. That being said, there are some instances where you can't avoid it, but you want to. And again, the fasteners all have neoprene washers that grommet, so when you compress it, it'll seal. But over time, when it moves and opens up that hole, that's where your issue comes in. But very good point and good question.
Okay, let's sneak in one more.
All
Would
right.
steel roof panels handle hail better than aluminum?
So my answer is depending on gauge, but Yeah, well, actually, yes, steel would, because steel has a memory. And I have some fantastic hail damage photos that if you're interested in, you can email me. I love problem photos and issues. So if anyone on the call has anything, send it to me. I love keeping a file on those. Hail will dent metal panels. Hail will penetrate single plies, for crying out loud. There was a single ply I took a picture of that had like thousands of holes in it from hail. Yes, steel would be better to use, especially in a heavier gauge, because it does have a memory. So you're not going to see little dents and divots all over it.
Okay, let's get back to your presentation and we'll do some more questions in a bit.
All right. Coatings. Aluminum zinc is widely used. It shouldn't be the most widely used. It's just, well, it probably is by a margin. It is very widely used coating, okay? Galvalume and Zincalume are the same dang thing, okay? Tissues, Kleenex. Charmin, toilet paper, right? Kirkland vodka, Grey Goose, for those of you. Same thing, okay? It's different trade names. Aluminum component of this coating is 55%, and it does the corrosion protection. The zinc component is the sacrificial characteristic. Okay. Metal comes in these coils that you can see here. If you're ever, oh, FYI, if you're ever by a truck that's carrying these on the road, stay away from it. This is like the most dangerous thing to transport. Stay away. Not good, right? Bare metal comes in, it's either coated with galvalume, zincalume, or galvanized. Here's the difference. All right. Galvanized G60, G90 does not carry a substrate warranty. Once again, galvanized does not carry a substrate warranty. So if you're dealing with a different manufacturer that's not me, and they say, oh, we have a galvanized panel, great. You have no substrate warranty. If there's a cost difference of like 10 cents per square foot, that might be it. Still wouldn't use it, okay? Galvanized has no warranty. So if a substitution request comes in, take a look what the substrate is. Aluminum zinc, or Galvalume Zincalume, does have a warranty, okay? That warranty is 25 to 40 years exposed. Excuse my next door neighbor's dog. Okay, substrates. After the substrates comes the paint systems, okay? You have polyester, it moves up to silicon modified polyester, and then you can move up from there to Kynar, all right? Polyester is your base stuff that coats that your ABC, your diamond supplies have on their sheets. Not very long for longevity. A better one is silicon modified polyesters, SMPs. SMPs can flex. This dog keeps going. I'm going to head inside. The silicon modified polyesters are used on lighter gauge metals, 28, 29, 26s, because they flex more. Think of the 28, 29, 26 gauge metals as a piece of paper that bends. You have to use a flexible paint system. Higher gauges, or thicker gauges, 22, 24, 20-ish, use Kynar, PVDF. That's more brittle. They can sustain it. You can't use Kynar on lighter gauges, okay? The warranties moving up. Kynar systems can carry a 40-year paint finish warranty now. SMPs carry a 20. Polyesters maybe a 5, and they'll weather out a lot sooner. So I'm going to go off track again here. When you're specifying things, make sure you state somewhere in your spec, all sheet metal, flashing and trim shall be sourced from the same manufacturer as the metal panel in order to, number one, maintain an exact color and paint system, and number two, a congruent warranty. Otherwise, your contractor may go off to ABC Supply, Diamond RSG, Roofing Supply Group, to a house and grab a polyester. Okay, you now have a, colonial red on your roof, on your walls, and your trim, the flat stock, is all made out of a colonial red that's polyester. It's going to weather out in 2 to 5 years, and your Kynar is good for 40. You're going to have like pink trim eventually with nice Kynar red that's going to maintain its color. Make sure they weather together, okay? Always get the flat stock, the pre-finished fasteners, all that from the same paint system manufacturer and so on as make the metal panels, okay? Very key. Okay, chalk and fade qualities of Kynar drastically outperform polyesters and so on. Yes, 100%. When you couple Kynar with the Galvalume Zincalume finish, you have a substrate warranty and a paint warranty. Awesome. If you do Kynar over galvanized, you don't have a substrate warranty. If it rusts, sucks for you. That's the difference, okay? All right, as you can see, it comes in the metal, you coat it with Zincalume Galvalume, then you paint it. The backer coat's typically a polyester, and the top coatings are typically Kynar for 24, 22, 20, or your lighter gauge is a SMP, silicon modified polyester. All right, I'm going to go off track again here real quick. One thing I want you to be aware of is the Kynar, what am I looking for? The Kynar, not pigment, it's not a pigment, the Kynar material, the Kynar goo, right, that we use to make it with, that is used as the separator in electric vehicle batteries, okay? Tesla and Toyota and Honda have a much bigger pull to get the PVDF material as compared to paint systems. So you may see Kynar start to get more expensive over time, and you may see manufacturers starting to move away on certain colors to a SMP as compared to Kynar. This may happen, it may not. Just into, looking forward, if you're like, man, why is this paint system, $1 more than it was 5 years ago? That's why. It's the separator in between the positive and negative on the EV batteries. Okay, getting back in. Warranties. I've talked about this. Not all warranties are the same. Make sure you look at the chalk and fade. Make sure you look at the substrate. Just because a substitution request comes in, it's 10% cheaper. Yeah, and now you have a silicon SMP paint system or polyester paint system over G90 or G60 versus what you had. It's not worth it. Pay attention to that. Sealants. There's two different types of sealants. One likes to see the sun, one doesn't. Butyl, non-curing, doesn't like the sun. It dries it out, right? You can pull a roof apart after 50 years. It's still gooey. It comes in caulkings. It comes in tapes, as you can see there. Butyl, non-curing, doesn't like to see the sun. Butyl is your night owl, okay? Urethanes, they're your daytime folks. They like to be exposed to sunlight. Urethanes go up against block, stucco, ephes, whatever else you interface with. They can be tinted to match the roof. Those are your urethanes. So urethanes are daytime. Butyls, again, non-curing. That's your nighttime stuff, right? It doesn't like to see UV. Okay. What's this slide on? Oh, let's jump into this real quick. ASTM versus UL. I think that there's a couple slides going down here. I'll talk about it here. ASTM is your push to failure. UL is your did it make it? And what I mean by that is ASTM is not the same as UL, okay? Let's say that you have a family member that needs to have a surgery done, okay? Do you want your family member to have the surgeon that passed the test, that got the 70% and now got their license, that is a realtor that got their 70% and got their license? Or do you want the best damn surgeon you can get? ASTM, push to failure. That's a ranking system, okay? ASTM, you can extrapolate it out. You know when the panel fails with that substrate, with those fasteners at this wind speed, okay? UL isn't that. UL is, did you make it to, I don't know, 1 hour burn time? Great, here's your certification. ASTM pushes that out. Take wind uplift, for example. We know that at this wind speed, at this clip spacing, the roof failed. So that's the difference between ASTM and UL. This slide, metal roofing is recyclable. We all knew that, right? Moving on. Okay. What is this one? This is cool. Oh, this is the cool one. Okay. So you may see cool in front of some paint names. Okay. This is how I think of it. I've got 3 kids ranging from 5 to 15, almost 6 to 15, right? I've watched a lot of Disney movies. Cool. Imagine Tinkerbell. Okay. Tinkerbell flies and fairy dust comes off. Stay with me, folks. Okay. Tinkerbell flies and fairy dust comes off. I imagine cool as a magic fairy dust that some brilliant chemist who's way smarter than me sprinkles in to the paint that doesn't change the pigment whatsoever, same color, but it drops the overall SRI. How you do that? It's legitimately a magic fairy dust, okay? Does not change the pigment. Your cool colonial red is the same as your colonial red. However, your colonial red has a higher SRI. Your cool matte gray has a lower SRI than your matte gray. Same color. That is all cool means, is Tinkerbell has flown by and magically infused this paint. That's all it means. Okay, SRIs, if you want to know how to read this, I can walk you through some of this. Certain colors are accepted, certain colors aren't, especially if you're in California and or a state that follows that similar energy code. You cannot use a certain color below a certain slope, low slope, below 2 and 12. It's basically white, white, or white. There's a lot of things that go into this, 1,600 or 2,200, depending on where you are, square feet over conditioned space, under 2 and 12. If you're not a conditioned space, like a pre-engineered metal building, you don't need this. But all this comes into play. Too much to go down this rabbit hole at this time. Okay, PV. Everyone wants to put PV on their roofs. Yes, don't put holes in your roof. Okay, use a clamp manufacturer. I can't say trade names in this presentation. So there's clamp manufacturers you can reach out to me on. I will provide them to you that make clamps that fit over the seams. Like this one right here is a bulb seam, right? It's got that bulb at the top. It's a mechanically seamed panel. There's a male and a female leg. So it's directional. This is a directional mechanically seamed, but it's a bulb, right? It fits over that. So this eliminates the need for penetrations. And I'm reading someone's aura that they're asking, Jeff, wouldn't this increase wind uplift on the panels if the wind gets underneath the PV? Great question, whoever mind I just read across the ether. Yes, increase the wind uplift. However, the additional clamping force of that set screw clamp on the panel seam negates the additional wind uplift. So we're good. This is what it looks like going down. This project was interesting. It was a key building. I forget what it was classified, but we had to put the spacing a little closer. I think it was 4 foot on center. You can push them out. Again, all this is here. There's UES, Universal Evaluation Services report with ASTM testing that pushes it to failure, that we can work in conjunction with roof systems. Again, that's why testing is so important, to push this through your said governmental back check. Okay, dissimilar metals. Keep copper off things, right? All right. You can put anything else up there with these clamps. You can do catwalk, you can do signage, you can do snow retention, snow melt, PV. You cannot do fall protection. All these manufacturers will say you can do fall protection. Keep in mind, they test their connection of the clip to the seam. That's it. I'm a 6'2", 210-pound dude, right? If I fell off, my force, that'll keep hooked to the seam, but the roof won't stay fastened to the substrate. So now I'm falling off a roof, connected to a tie-off, connected to the clamp, connected to the roof, and the roof's going to come down on me, okay? Always tie fall protection to the structure itself through the use of a davit or a D-ring. Enough said. Questions, number 2.
Okay, Jeff, we have more questions coming in. In industrial roofing, how do you prevent denting at attachments in the high point of the rib?
Okay, so industrial roofing, you've been paying attention, you know that that's a through fasten panel, and you're going to fasten through the high point of the rib. You set the clutch on the drill or screw gun to clutch at a certain point that correctly drives that fastener and compresses the neoprene washer just enough to where it looks like a little inner tube. Okay, that'll be information conveyed from the screw manufacturer, but I'm telling you, that's like basic stuff for the guys that install this, for the people that install this. So you drive that fastener just enough to compress the washer. If it's overdriven and it's squished and it looks like it's coming out, it's overdriven. That's not good. That will dent. So the key is the clutch on your drill.
Okay. Do you have any recommendations for confirming the gauge of metal in the field? I've seen sheet metal gauges, but due to the coatings, thicknesses can vary.
Third gold star of the day. Good job. Okay, you are correct. Gauges of metal have a certain range under SMACNA. You can look it up. 24 gauges X, and I forget off the top of my head. 24 gauges this, 22 gauges this. The coatings have a thickness. So what you can do is you can measure it with a field measuring tool, and then you can add on the thickness after. Okay, you can either subtract or add on after you measure. The field measuring tools, they also make ones for a base Kynar system as well that I've seen that come from the actual paint manufacturers. There's two main manufacturers. I want to say PPG and then I want to say Sherwin-Williams. But they make them, but you can add or subtract. That's a good question. You can measure that in the field though. And there's a variance.
Is there a preferred detail to use for standing seam hip caps to avoid oil canning?
So yes, there is. That's a question that's much more in depth. If you can email me offline, I can send you some examples. It's going to be hard to talk through without showing everything, but yes, there is.
Okay, there's a few more questions, but let's save those till the end. We'll get back to your presentation for now.
All righty. Okay. We're going to blast through this in the interest of time. I got about 15 minutes. Wind is the largest factor that fails in roof design, right? Improper design and clip spacing for wind. Okay, we can do site-specific calcs that take into consideration a bunch of variables: building height, slope, size, exposure, building type, that put in and they come back with a zone calc for each clip spacing. There's more than 3 zones now. I know we all know this, but zone 1, 2, and 3 are the traditional ones: corners, edges, and field. Right, so we can get this all dialed in site specific. These are the tests that are used. Again, in the interest of time, I'm going to skip past this and get to some more interesting stuff. So I had talked about a lapped panel prior. Actually, I'm going to dive into that later. I'm going to skip past this in the interest of time. So universal evaluation services, these take the ASTM testing and they extrapolate it out. This is your ICC, your IATMO, your Intitech, or your ULs. If you look at this right here, for example, you're going to look at what the panel type is. It has its own panel type. This is a 12-inch wide panel. This is what gauge it is. This is your span, and this is your clip spacing, site-specific as it goes out. This is the one that I like to pay attention to the most, your negative, which is what takes roofs off. This is your substrate. You start with your substrate, you move to what gauge your substrate is, 2 fasteners per clip. So by the time you reach this column, you're going to know what your substrate is and what gauge. 16, that is this row only. 2 fasteners. You're going to use a number 12 fastener. That is this middle row. These are your values with the clips at the said spacing. So at 2 foot on center, 176 per square foot, 16 gauge into grade 50. That is off the chart, right? That's like Florida, exceeds Florida. Anyway, that's how you read those. I can walk you through it later. Different metals have different performance characteristics, of course. Okay, let's get into this. Thermal movement for roofing. You can accommodate at the high end at the ridge, in the middle with a fixed clip, or at the low end at the eave. Duh. Okay. All right. You pin at the top. Let's say you have the 2-piece clip that moves back and forth. As it runs down the slope, it can only move plus or minus 1 inch. That puts you at 80 foot max, not 75. There's a safety factor there. If steel moves 1/8 of an inch over 10 foot thick and 80 foot panels, the longest panel you can run with it pinned at the ridge. Or you put a fixed clip in the middle, then you float one side up and one side down. So if you have a 100-foot long building, like I said earlier, and you don't want to spend all the money for on-site roll forming, the crane operation, site access, site control, and a literal surgeon that operates that crane, you can lap the panels. But Someone is asking this through the ether again. Jeff, let me skip ahead. Jeff, how do you lap panels if you said they won't fit inside each other? Aha, good question, my friend through the ether. It's called swedging. You can swedge 2 feet of the panel. You see these marks that look like little bubbles? It's like an airplane canopy. There's a bubble and it tapers back. That takes the panel and squishes it together just enough so you can lap it inside the other, and these fit tight, okay? You can't go more than 2 feet. This is a swedge tool. So you can't ship them like this, but you can swedge them. You stagger the laps so the roof moves as a uniform plane, and a uniform, what am I looking for? Plane roofing system, a uniform section, and it doesn't have one line across that can separate, okay? That's how you do that. All right, going back. Eave, the eave floats. There's a joggle cleat that goes around this eave, wraps around, and the eave expands and contracts. It's pinned at the head. This panel will move at the eave. That's a floating eave condition. Okay. All of you, I know at one point, have thought you've wanted to do a snip in the panel where it goes down the roof and then folds down the wall. It's called a waterfall or a roof-to-wall transition. Looks fantastic. Yes, it does. There's things you need to consider with this, though. When you snip the ribs and fold it over the wall, like that, even if it's mansard, it's a foot tall, this is now a point of fixity. The metal cannot move here. You must float it up slope now. You have pinned it at the eave, okay? That's why you float the roof at the ridge. Don't use them in snow, okay? Moisture gets in there. Freeze, thaw, pop, okay? Also, snow going down the roof can rip these things straight off. So a floating ridge also can be a vented ridge. There's a step in the ridge cap right here. You fasten it to the Z, and this step scoots in and out as the panels come up and the ridge flexes in and out like this, okay? All right. For longer roof runs where you want to pin in the middle, there's my photo. There's a point of fixity in the middle. You float up and you float down. Again, this is only for panels that don't have unlimited thermal movement. If you have an unlimited thermal movement panel, you're good to go. Okay, fixed clip in the middle, your swedge lines, your lap, your fixed clip in the middle holds those, floating clip upslip, floating upslope, and a floating clip downslope. The roof goes like this, out on both sides. You need a floating eave and a floating ridge. Okay, this is often used with barrel roofs. You fix it in the middle, pull the panels up, lap them, done deal. Okay, makes it much easier than craning in a curved panel and placing it. All right, drag load. You must fasten all your panels so they don't slide off the roof. I did a project once at Donner Pass in California, which is, if you're familiar with the Donner Party, right? It snows that much, has the highest snow load in the country, I believe. We needed 42 fasteners per panel to hold the drag load, okay? It's an absolute must. Also, I was talking about this earlier, the snow can come down and crush all of your penetrations. Push them up as high as you can. If you push your penetrations towards the ridge, there's less material to get behind it, right? So push them up towards the ridge. This broke, it's got crushed because the snow came down 50 foot of roof, right, before it went off. You can use those same clamps that you do PV, signage, catwalk, stuff like this, snow melt, snow retention, but not fall protection. Not fall protection, we all learned. You can do stuff like this and protect it so it splits the snow as it goes around. This was up in Truckee, I believe. Snow retention, again, same set screws, same clamps as I talked about for PV. Okay, wide valleys, right? Wide valleys are the key in high areas with high rain and high snow. And the reason is, if you go all the way up that valley in the right-hand side photo, and you look at the top, there's only 2 panels that come into that valley. So if it rains, say you're in Seattle or Portland, right? It rains, you're in Seattle. And that water comes down 2 panels and it hits and it goes down. As you move further down, more and more panels are merging water onto this valley, and it's getting more and more congested and more turbulent. By the time you get down to the bottom, Every single panel run above that has water coming out. So make the valley wider to accommodate. Okay. Pay attention to this one. I know this is basic. Never, ever, ever fasten a pipe boot through the panel into the substrate, okay? Pipe boots are slinkies. They're designed to move. Actually, this penetration stays solid, so this up top, and it moves with the panel as it expands and contracts, okay? It moves. If you fasten it through the panel into the substrate, when the panel moves, you've thermally pinned the panel. Now it's going to do that, okay? Only fasten the pipe boot to the panel itself. It is supposed to move with the panel. If you have a pipe boot, it goes in the middle of the panel. If you have a pipe boot that is off center or larger than one panel width, you use a home plate detail. So pipe boots 1 panel width, home plate detail like this is 2 panel widths, right? Not good, good, not good, good. You see how these pipe penetrations could fit within a panel width, but they're off center? You don't want to ever interrupt a seam, okay? So 1 panel width in the middle with fingers on either side so water can go around, pipe boot. Anything over that is a home plate. Sorry, 2 widths or more is a home plate. Anything 3 or more is a curb. Put a curb up. You can mount anything you want on curbs, from HVAC to skylights to solar tubes to whatever, vents. All right, curb. I made it, and we have time for questions. This is my favorite part. Okay, we did it.
Okay, yeah, we have a few more minutes, so send in some questions, guys, if you have them. Next question for Jeff is, are there any pros or cons between using a wide or narrow batten seam?
Absolutely fantastic question. And as I'm going to talk about this, I'm going to go back and try to find that one. I think it's way back here because I want to show you this in like a photo. Okay, where are we here? There we go. Okay, narrow batten in the bottom left. They come together and it goes up. There's a little gap in between. Same clip, tabs fold over. If you do a wide batten, they come together and there's a wider gap in between. That is an unprotected, unwaterproof gap. The batten is what covers it. Okay, so technically, you have more of a risk, more open area with a wide batten seam as compared to a narrow batten. Also, the performance is nowhere near the same for a wide batten as a narrow. That one clip is straight up and down with tabs, holds the narrow batten, right? A wide clip has this, and so what holds it is a centerpiece, and it can get bent up under wind. So the wind uplift and the performance is not as good with wide batten as it is with narrow batten. I prefer narrow batten if you want to go the narrow batten route. However, there are decorative battens. So if you want that wide batten look, you can use a snap style panel like this that's good down to 112, you know, with a watertight warranty for 20, 25, 30 years. And you put a decorative wide batten over it. Problem solved, right? Now you have the waterproofing of an encapsulating panel leg and a wide batten. But great question. I'll give you a gold star too.
Okay, another great question. What is the lifespan of a standing seam metal roof?
Oh, I have such a cool photo that I want to show you. Okay. Standing seam metal roofs. I have been on one that has gone for 100 years. Okay. It is called Heilbronn Mansion. It is in Sacramento, California, and it is a ball peen hammer standing seam roof. That means someone in early 1900s, okay, pre-World War I, right? Okay, like when horses were everywhere, cars were limited. Took a wood form that was long and a piece of tin, and took a back of a hammer, a ball peen hammer, and hammered in that bend so it bent up into a standing seam leg. Put it up on the mansion, and then took another one and hammered it over the top. Okay, standing. I've seen this roof. I've been on it in person. I have photos. If you're interested, I'll send them to you. They can go a long time. If you're specifying a roof from my company, we can leak-free guarantee it for up to 30 years, right? 20, 25, 30 years. Most leak-free warranties are 20 years, so you stay competitive because most companies can't do a 30-year warranty. The 20 years is most common. If it goes for 20 years and your paint finish warranties for 40 years, this roof's going to go, if it's done correctly, 50, 100 years. No joke. So the lifespan is very long if you do it correctly with a concealed fastener standing seam and a thicker gauge.
Is there a recommendation for type of seam for standing seam roof that works best for PV clamps?
No, there's not. Well, batten seams don't work as well, okay? These type of battens, you can do a bulb seam or a T-seam. I think the PV one had a bulb seam in there. Bulb seam and T-seam battens will work, but typically you want an interlocking panel leg because it puts pressure on either side. And if you put pressure on either side of a batten, it can pull off, whereas a mechanically seamed or snap lock has that locked leg. But they make clamps for everything, including exposed fastener roofs that fit over sine waves or fit over box ribs and so on. They make clamps for everything. You can go in and do a drop down. Generally speaking, I would use snap lock or mechanically seamed if I was going to install PV, because performance is higher, number one, and the clamp sets that encapsulating leg.
Can you comment regarding crickets behind penetrations?
Yes. Okay. So they should oftentimes be used. I have a curb. You don't need them at pipe penetrations. Pipe penetrations, you want one hand width on either side of the panel. A cricket's not needed. On the home plate detail, this has a built-in cricket, as you can see. Only place crickets are really needed are on large curbs. And this is typically 3 panels doesn't necessarily need, if you're going to go 4 or 5 or larger, you want to build in a cricket. And these are typically fabricated in the field out of flat stock by your metal sub, or the curb that you purchase comes with one pre-manufactured. But generally speaking, you only see crickets on very large curbs, not pipe penetrations, not home plate details, because that has it built in, right? That has the cricket built into divert water.
What is your recommended detail for transitioning from sloped to vertical standing seam? What is the best practice for the waterfall detail?
Okay. I wrote an article on this. It was published in Metal Architecture and your magazine as well, right? It was published in this, and it talks about how. Okay, so let me go back to it real quick. I have an article. Reach out to me. So as it comes down from the roof, you have to do a floating ridge, right? Because it has to expand upslope, because this is the point of fixity. Okay, as you clip those 2 ribs, it'll fold down the wall. If you have a long panel run, you're going to have to your metal sub will use a scissor lift, and they'll walk the panel down the wall so it doesn't go wonky on them to side, so it folds straight. Then you use what's called a kneecap. A kneecap is a piece of metal that we can manufacture, or they can make in the field, that has sealant, and you pop rivet it on either side. This is the detail that's used for a kneecap. There's no other detail for it. The panel has to be able to float upslope and downslope, and this is a very touchy detail. If you're interested in my article, reach out to Stacy, and she can put you in contact with me, or copy that one. Oh, section 1. I went too far. Copy my email and send me an email on it, and I'll get my article to you. Go ahead. Next question.
Okay, next question. How long can you go before you worry about the thermal expansion on the length of the roof?
So the worry is within the limitations of a clip. Okay, if you have an unlimited thermal movement panel, like a T-seam or a snap lock, and you want to roll form it on site in one length, it can move. Typically speaking, you can do 150, 200 foot single length panel. It's going to move a lot at the end. And again, it moves more where it cycles a lot, right? If like you're in the Mojave Desert, where it's like the hottest point that our country's ever hit, and it drops down to like freezing, snowing at night, that's a wide temperature range. The metal's going to move a lot more because metal likes to move and party. There's no real rule of thumb for that. It is within the clip limitations themselves. But as I've discussed, even with a 2-piece clip that does have limitations, you can accommodate for that with a pin in the middle. So there's ways to get around it, but I've seen a 180-foot roof. That's a big old roof, and we did that with 2 panels. So it's around the product itself. Hope that answered it.
Okay, let's do one last question. Can any standing seam panels be swedged, or is that option specific to certain panels?
That option is going to be specific to certain panels. I have seen panels that may not be swedged, that cannot be swedged. I would reach out to your manufacturer. It's manufacturer specific. What I can tell you is every panel that we manufacture can be swedged.
Okay, that is all the time we have for today. Jeff, just so you know, in addition to the Q&As or the questions coming in, we had a lot of comments about what a great presentation that was.
Oh, thanks.
So thank you. And thanks to everyone who joined us today. That's all the time we have. If you need to reach out with any additional questions, Jeff's contact info is currently up on the screen. Just a reminder before everyone leaves, if you would like to rewatch today's presentation or share it with a colleague, we'll be emailing the link to the recording to everyone who registered for the webinar within a week. Once again, it may take up to 5 business days if you are requiring a certificate, so keep an eye out on your inbox and don't forget to check your spam or junk folders. Finally, after you shut down Zoom, you'll be taken to a survey to provide feedback on your experience today. Please take a moment to complete the survey as it helps us to continue to serve your needs in the future. Thanks again, everyone. Have a great day.
Thank you all for attending.